Yeah. Yeah, we're under a tornado watch or whatever.
We are. We can ask Kevin and Stephen about it.
Christopher's topic is on this thing.
It's very
Tornado
timely,
shelter.
Christopher.
Yeah, this is the spring season is when the tornado frequency peaks. So we're approaching that time.
Yeah. Okay.
Four different pages, right?
Yeah. Maybe four different ones. Just look at the chassis.
Can y'all hear me?
Yes.
Yeah, we can hear you.
Yes. Hello, everybody. It's 3 o'clock. That means the colloquium has officially started. We have our Masters of Science Geography students today who will be presenting their posters. There will be 4 participants. We welcome all the participants. They did a marvelous job on these posters. Here's what we're gonna do. We're gonna proceed, let them do a 5 to 7, 10-minute presentation, somewhere thereabouts, and then we'll take questions after each of the presentations. So without further ado, let's start. Meirah Williamson will go first. Take her away, Meirah. You can share your screen now.
All right, thank you, Dr. Feck. All right, can everyone see my poster? Awesome, okay. All right, so just move this bar out of the way. All right, so today I'll be talking about my master's research, which is titled Damages Associated with Excessive Rainfall Outlooks and Missed Flash Floods. So flash floods are the most damaging and deadly type of flooding in the continental United States, and the excessive rainfall outlook has been used by the Weather Prediction Center to highlight regions at risk of flash floods in some form since 1978. And they're based on quantitative precipitation forecasts, but they go a step further by recognizing that the relationship between flash floods and precipitation is not linear. So various factors such as land use, topography, basin size, soil moisture, and stream flow are all key to forecasting flash flood risk using EROs, as is weather forecasters recognizing weather patterns typically associated with heavy rainfall. And an ERO has 4 risk categories, as you can see on the map on the right side of your screen. You can zoom in a little bit. In green, there is a marginal risk or a less than 10% chance of flash flooding occurring in that area. In yellow, a slight risk or a 10 to 20% chance. In red, a moderate risk or a 20 to 50% chance. And then in pink is a high risk or a greater than 50% chance of flash flooding. And so the data I used was about 4 years worth of data spanning from September 2016 to August 2020. And we chose the start date because this green marginal risk category wasn't added until August of, or I'm sorry, I forgot to get to my question. So while EROs have been validated by the Weather Prediction Center across several metrics, an analysis of flash flooding events that occurred but were not forecast by excessive rainfall outlooks has not been performed, nor has a spatial analysis of the monetary damages associated with missed flash floods. The WPC also hasn't looked at flash floods or at damages at these different ERO risk levels. So this marginal, slight, moderate, and high. And so now to get to my data, we use data spanning from September 2016 to August 2020. We specifically use day 1 EROs, which are EROs that forecast the risk of flash flooding within the next 24 hours or about 1 day out. And this all comes from the Unified Flooding Verification System, which is a suite of 4 flash flooding proxies and observations that the WPC uses to verify their own EROs. We use damage data from the Storm Events database, which is hosted by NOAA. And then I wrote scripts in Python and used some ArcGIS tools to complete this analysis. And so I'm not going to go too much into the meat of my methods, just so I can make sure to get through all of my results, but I'm happy to take questions about those afterwards. And so first, we went ahead and looked at the flash floods that were missed by excessive rainfall outlooks. And so you can see in this map on the left-hand side of your screen, right here, spatial distributions seasonally of these missed flash floods. And summer might pop out to you right away. The missed flash floods are mostly concentrated directly east of the Rockies and then also east of the Mississippi, through the lower Mississippi River Valley, up through the Appalachians and in the Ohio River Valley. There are just significantly more days and more missed flash flooding events in summer. And based on a literature review and some further research, this is mostly due to widespread summer convection, which is just very difficult to forecast. There are also a lot of difficulties forecasting precipitation due to the North American monsoon, which occurs in the southwest of the United States, and then tropical systems really dominate missed flash floods and just flash floods generally along the Gulf Coast and up through the Atlantic. And in winter, you might notice that there are some hotspots up in the Cascade Mountain regions and in the Sierra Nevada, so all along the west coast of the United States. And a lot of these misses and a lot of flash floods generally come from atmospheric rivers in these regions. And so drawing your attention to this map at the center of your screen, this is a map of the seasonal damages that were missed by flash floods as a percentage of damages from all flash flooding events. And so we decided to depict it this way in order just to give a sense of really what the percentage or how many damages out of all damages were being missed by excessive rainfall outlooks. And so you can see maybe a region that didn't pop out as much in the distributions of missed flash floods is really the Southwest US. And again, a lot of these missed damages, up to 72% of missed damages in the Southwest are caused by this North American monsoon. But interestingly, about 68% of the damages that are correctly forecast by EROs from flash floods are also from the North American monsoon. So it's not like the North American monsoon is causing really a big discrepancy in forecasting these EROs. And overall, missed flash flood damages actually really don't account for a whole lot of all flash flood damages. They're only about 3.4% or $170 million of the total of $5 billion of damages caused by flash floods over the course of this 4-year period. And so our second question went ahead and looked at EROs and damages at different risk levels. So again, this marginal, slight, moderate, and high risk. And so on the bottom left of your screen are just spatial distribution at the county level of where these EROs tend to fall. You can see they're pretty marginal risks are pretty widespread and occur frequently. And then as we get to high risk, high risks are mostly dominated by tropical systems. You can see they really hug the Gulf Coast and then up through the Atlantic. And then also some atmospheric rivers, again, out in the Southwest US. In terms of damages, much like the actual risks themselves, marginal and slight, these damages are pretty widespread. And then these damages that you see here are in millions of dollars per flood report. And so, yes, very widespread at the marginal and slight risk levels. As we get to high risk, you can see that they really start to be concentrated on the coast, and you can actually pick out specific flood and tropical system events. So the really high damage events that you see in Texas, that is Hurricane Harvey exclusively. Out in North Carolina, that is only Hurricane Florence. And sure enough, when we look at the bulk statistics of damages per flood report at all of these different ERO risk levels, they are the lowest, statistically the lowest, marginal risks, only about $500,000 per flood report. And then this number creeps up with each risk level. So at the slight risk, we have about $1 million in damages per flood report. At the moderate risk, we have about $8 million in damages per flood report. And then as we get to the high risk, we have a huge jump up to $245 million on average per flood report. And again, those are due to those huge tropical systems in the east and then atmospheric rivers in the west. And just to kind of wrap up this work, the storm events database, although and just with some caveats, it is a very comprehensive database for examining monetary damages from severe weather events. It is not complete, meaning that flash flood damages could be underreported or even possibly overreported in the case of people making flash flood damage estimates. Another important thing to note is that EROs do become a lot more accurate the closer they are issued to the event, but we chose these day one EROs that are forecast about with a 24-hour lead time because they are more accessible to the public and also to emergency managers, and they're also more relevant. It's probably easier to have about 24 hours to prepare for a flood event instead of 3 hours, which is another timescale that EROs are issued at. Thirdly, EROs are not meant to capture every flash flood event, but what we wanted to do is just kind of show a spatial distribution of where the most missed flash flooding events are. So even if there are isolated flash flood events, if it's happening repeatedly, it might be an area for the Weather Prediction Center to look at. And then some future work could include investigating some specific meteorological and physical drivers of especially damaging events in other areas across the country. We did look a bit at the Southwest, but a deeper dive could be done there, and then also maybe up in the Ohio River Valley. And then another thing we hope to get to kind of way at the beginning of this research, but just didn't have time to, is looking at day 2 and day 3 EROs. So day 2 EROs are issued for flash flooding events 2 days in advance, and then day 3 EROs are 3 days in advance. So just kind of seeing what those spatial patterns look like when these flash flooding events are further out. And so with that, I just wanted to thank my advisor, Dr. Mullins, my committee members, Dr. Ash and Dr. Whalen, and then also Dr. Mike Erickson at the Weather Prediction Center, who really helped guide this research and kind of told us what the Weather Prediction Center was interested in and what kinds of questions they'd like answered. All right, and I'll take questions. Thanks.
Any questions from our audience? I have a quick question concerning the data. Is there something specific about the period that you looked at that might give you unusual results, or is it just, do you think that the period and the time framework that you looked at gave you reasonable results that are pretty typical of what might be going on in terms of the spatial pattern, spatial distribution.
I do think it's pretty reasonable. The reason we chose September 2016 as a start date is because the marginal category did not exist before that, so we wanted to make sure that this was consistent. The last paper that Mike Erickson from the WPC put out also looked at 4 years worth of data for their verification. I believe it was 2011 to 2015, so I feel pretty confident that this is all right. Yeah, thanks.
Okay, good answer. Good, very good.
Thank
Very
you.
good. Anybody else? Okay, we're going to turn this over now to Holli Capps.
Okay, can you guys hear me?
Yep.
Okay. All right, so I will be presenting on some of my master's research on extreme daily rainfalls in Ghana. There are several reasons why understanding the variability of rainfall in Ghana is important, but not limited to rain-fed agriculture providing most of the country's employment, GDP, and food security. The variability of extreme precipitation is likely to change under climate change, could lead to more events and lead to larger magnitude events, which could lead to risks associated with crop damages, flooding, soil erosion, among other things. 19 long-term meteorological stations were used, covering years from about 1960 to 2013. There are 4 main questions that guided this research. Is there evidence of significant interdecadal scale variability in the characteristics of extremes as suggested by the literature concerning more general measures of precipitation? Are there significant differences or regional patterns in the characteristics of extreme rainfalls between time periods? And can findings be extended to various definitions of what exactly constitutes extreme rainfalls? There are several ways to go about defining extremes. One common approach is the peak over threshold method. The peak over threshold approach sets a threshold either based on physical events by rare quantiles or other statistical and mathematical methods. Then all the values over that threshold are considered extreme and are used in further analysis. There are several ways to go about setting a threshold. In this case, the threshold is based on frequency or risk to preserve some of the inherent rainfall patterns in Ghana. That is a general decrease in precipitation from south to north. Extremes are relative, so what is considered an extreme event in northern Ghana may vary slightly in magnitude compared to southern Ghana. Therefore, a common truncation level can be used to facilitate geographic comparisons, but which is common in terms of its comparative rareness at each location. The 90th percentile is used as the threshold in this case, and there are 3 characteristics that are investigated. The peak over the threshold, or the magnitude, the frequency of events per year, and then the cumulative day of the year, or timing. Additionally, the Mann-Whitney U-test is used to define significant breaks and defined the overarching time periods, with the West African drought from roughly 1970 to 1990, as mentioned and defined by the literature in mind. The hypergeometric test is used to look for statistically significant differences in magnitude and frequency to be summarized using the median quotient, and the KS test is used to look for statistically significant differences in timing. Finally, exponential and Poisson distributions are fit to period 3 data. Magnitude and frequency of extreme daily rainfalls follows a similar pattern to the literature, where we might say that period 1 is pre-drought, period 2 is drought, and period 3 is post-drought potential recovery. while the timing of extreme rainfalls does not follow that same pattern. Figures 3 and 4 show the differences in the time periods between each of the three variables, with this being magnitudes, frequency, and timing. And then the exponential distribution fit to the magnitude of events and Poisson to the frequency of events can be used to predict properties at even higher thresholds. Delimitation of time periods was needed to investigate whether the characteristics of extreme daily rainfalls had returned to pre-drought conditions, in reference to the partial ongoing recovery in other descriptors of precipitation. There are general patterns and conclusions that can be drawn about the changes in magnitude and frequency. However, figure 6 shows that only a few stations actually showed statistically significant differences, which could be in part due to subsample sizes being small and that extremes are usually very noisy. However, the coastal strip appears to have made the least amount of recovery with continued differences from pre-drought conditions, while the rest of the country seems to be returning towards pre-drought conditions, though not completely so. And then in mid-eastern Ghana, Lake Volta could be potentially skewing recovery results there. Differences appear to be greater for frequency of events rather than magnitude. The discussion of timing is complicated by the difference in the number of rainy seasons from north to south. And inter-period differences in timing are relatively small compared to within period variability, and the KS test did not yield any significant differences in the timing of extreme daily rainfalls from period 1 to period 2. And in the presence of evident changes in frequency and magnitudes, current best estimates of near-term risks are best characterized by distributions displayed in period 3, despite the limited sample sizes. Finally, this research provides a national review of the characteristics of magnitude, frequency, and timing of extreme rainfalls. It addresses the question of whether this part of climate has returned to pre-1970 levels. It helps provide some insight into one of the concerns that climate change is occurring, in this case as an increase or change in the frequency and or magnitude of extreme events. It identifies a potentially complex response in a latitudinally defined region to interdecadal changes, and it suggests a tool that may be used to estimate extreme events at even higher levels. And then I also wanted to thank Dr. Whalen and my committee for their advice and help, and Dr. Kojo Owusu for the data, and my cat Nala, because she's awesome.
Awesome. Questions? Questions out there?
So if anyone has questions.
Questions? Speak
I have
now.
one. I have one.
Hey, Esther.
Okay, yeah. I was just, yeah, I like the shout out to the cat. My cat is currently sitting on my lap. You mentioned, the issue of
My
climate.
sound might have gone out again.
And also, interdecadal variability. What do you think perhaps might explain this period more, in terms of whether or not there's more of a sort of natural variability versus a climate change signal?
Alt-H. Oops. Sorry, y'all. This would happen to me. Cat's sitting.
She is having difficulty hearing. If you want to send her the question via text on the chat, that would be the way to go.
Okay. So for some reason, even though I had this working where I could hear people earlier, now for whatever reason, it's decided to stop working again. So Esther, I noticed that you unmuted potentially to ask a question. Could you type it in the chat? So I think that the change in frequency could potentially be climate change. A lot of the other things could just be interdecadal variability, you know, between, like obviously there was that drought. So there was a baseline here and then lower, and then we're trying to see if it's going back this way. So that's just climate variability. But precipitation and especially extremes could definitely become more frequent as a result of climate change.
Any other questions? Please type them in the chat if you have them. In fact, you could still ask Holly some questions. We move on to the next one. So we're going to move forward. Okay. Christopher Williams, we're going to turn it over to you.
It was working just fine.
That's okay.
Okay, well, if there's no more questions, I will stop sharing my screen and I can always answer more questions later.
Okay, we're going to turn it over to Christopher. You're going to take over the, okay, share screen.
Hi, can you
Yep, you're good.
see my screen? Okay.
Hasn't loaded yet. We're waiting
Okay.
for it.
Yeah, my computer seems frozen at the moment too.
Put this on. Let's see what happens. There we go. There we go.
Can you see my screen now?
Yes, awesome. You can start now. Thank you.
Excellent. Hi, everyone. So my name is Christopher Williams, and today I'd like to talk to you about my thesis research. Today marks just over a year since the World Health Organization declared the COVID-19 pandemic. However, the onset timing in spring meant that the central and eastern US also needed to deal with the risk posed by tornadoes, as climatologically tornadoes reach peak frequency and intensity in April, May, and June. The compound hazards of the COVID-19 pandemic and spring tornado season created a recommended response paradox, because for one hazard, trusted authorities recommended people avoid large gatherings, quarantine, and isolate if they get infected, while for the other hazard, they recommended people minimize their exposure to tornadic winds and debris by sheltering in what is often group settings. So perhaps it's one's basement or the central room of a well-built home. If people do not have access to these resources, then they may seek safety in a public tornado shelter or in the storm shelter or sturdier housing of friends and family. So in particular, people living in manufactured and mobile housing seek shelter at designated public tornado facilities or with their friends and family. So we were interested in this research question. How did group tornado sheltering in the novel coronavirus disease or COVID-19 pandemic intersect in terms of risk perception and intended protective behavior during spring 2020? For this, our data, we used a Qualtrics online survey that was provided by NOAA in partnership with the University of Florida and the University of Oklahoma. This survey was conducted during a 2-week window in May 2020 last year from in the 20 states that are highlighted in dark gray. And there were 3,071 respondents for this survey. The topics, there were several topics, but the ones that we focused on are highlighted in black. And those include tornado sheltering during COVID-19 and different household characteristics and socio-demographics. So the variables that we focused on in this survey are shown in two, and each of the colors correspond to the colors over in the results section. So I have dotted lines connecting them. These variable names are shorthand notations because in the survey, respondents were asked questions. And so I try to make it as descriptive as possible. So one of the variables asked respondents, people to state whether or not they were more interested in protecting their household from COVID-19 or from tornadoes, for example. There was a variable that we created, a composite, that basically asked people if they would seek shelter elsewhere outside of their home. And elsewhere, that includes public tornado shelters, or private storm shelter, or in the housing, sturdier housing of friends and family. Another variable asked respondents whether they would turn shelter seekers away from their own home. And so I won't read all of the details here. The independent variable that we looked at is the housing type. So the US population that lives in manufactured and mobile homes is 7%, but about 50% of tornado fatalities occur from people living in these manufactured and mobile homes. So we decided to separate this, using this variable, we separated the housing types based on whether or not they were a manufactured home, a mobile home, a tiny home, or an RV, and we categorized them as less sturdy. And then for the more sturdy group, we included single family homes, townhomes or duplexes, apartments or condos. And dividing it that way created about almost 50-50 split. In the survey, we used the Likert scale, which instead of asking people categorically if they agree or disagree, it provides information about their level of agreement or disagreement. So this 7-point scale ranges from 1, which means strongly disagree, to 7, which means strongly agree, and 4 means neither agree nor disagree. So this 7-point scale is useful for interpreting the response means in the results. And we used SPSS and conducted univariate analyses. We looked at Cronbach's alpha when we were creating the composites, and we verified data and normality assumptions, and then we conducted t-tests. So I'm also going to talk about emergency management interviews that we conducted. So we wanted to get a better understanding of a key stakeholder perspective. And we established an interview protocol, and we were granted IRB approval. And so we conducted these interviews via Zoom, and each interview lasted about 45 minutes. We conducted a total of 9 interviews with officials across the southeastern US, and those 9 officials represent a 39% response rate. I'm still working on the thematic analysis, which I'm using in vivo to do that. And so this has been a really interesting aspect of the research as well. So now I'd just like to highlight a few of the results. One of the things, talking about the emergency management interviews, here is an excerpt that kind of is descriptive and illustrative of the how COVID-19 had an impact on emergency management operations. So one of the interviewees said, "We find that people sat in their cars at the shelter and did not come in until the warning was issued." It's like, yeah, we got 20 cars out there, we got 30 cars, but they're not coming in until they have to. So COVID-19 definitely had an impact on the way that people decided to choose shelter, and the way that emergency management officials went about doing their business. So below that, I show response means from the t-test, also comparing the less sturdy group to the more sturdy group. To the left of those means we show all. So this represents the entire group when it's not separated into less sturdy and more sturdy. All of the means were very close to 4. That was the modal response. The highest means were for the second dependent variable, which is protecting people more interested in protecting their family from COVID-19. And then the last variable, which people expressed, they thought that the protection information provided by public officials was unclear. So then if you move over a column, that shows the means for the less sturdy group, and then the third column shows the means for the more sturdy group. And we subtracted those, and whenever the difference, the confidence interval on the difference did not include 0, we concluded that that was statistically significant at the 95% confidence level. And we can see that the dependent variables, the first 5, were statistically significant, and the last 2 were not. In particular, I guess I'm going to focus a little bit more on the turn shelter seekers away variable for the spatial results. So if we move over to the green map with the central and eastern US, those are the results for showing the COVID-19 case rate during that month of May in 2020. And the lighter colors indicate a higher case rate, and the darker colors indicate a lower case rate. We can see some regions in the US like middle Mississippi, lower Alabama, southern Georgia. They had higher case rates during that time in May last year. Right here closer to Gainesville in central and northern Florida, there's a few counties where the case rate was lower. But you can see differences all across the US, and this was really helpful. The map to the right of that shows the locations, the ZCTA centroid points for all of the respondents. And some of those points are coincident, so they're plotted on top of one another. We can see that there was a large response from people in Texas and North Carolina. The state with the fewest respondents was Kansas. So we looked at the responses in a number of ways, and this is just a highlight of them. One of the findings from the statistical analysis showed that the modal response for all the dependent variables was neither agree nor disagree. And we wanted to know if there was some geographic clustering or anything with the way people responded. And so, for example, for the turn shelter seekers away variable, it shows that there is this large contingent of states in the Midwest where these means are closely clustered together. And then Louisiana and Florida are neutral. And then there's a large state component where it's a little less in between. And if you look at the tessellation hexagons, this is a finer resolution, and the bands for the response means are a little different here. So comparing the two isn't a one-to-one comparison. It shows a little bit more detail, and we can see, for example, that regions where, so let's look at this. Florida, for example, in the state response, it's neutral. But when we go to the hexagonal tessellation grid, we can see that there's more variation. For example, southern Florida, they have higher response means, whereas the central portion of the state have lower response means. And part of this we thought may be related to the COVID-19 situation during that time. Southern Florida had a higher case rate than central and northern Florida. So we're really interested in how this intersection related to risk perception and the intended protective behavior of people during spring 2020. I have here, let's see, it shows up. Okay, so here are some preliminary findings. In general, both housing type groups tended to see COVID-19 as a greater concern than tornadoes. And this was especially so for respondents living in more sturdy homes. The less sturdy group tended to prefer seeking shelter from tornadoes away from home, despite COVID-19. Both housing type groups view comprehensive risk reduction communication coming from official public channels as lacking clarity. For the spatial analysis that we did, we found that numerous coincident points did not work well for the ArcGIS tools that we were using. For the emergency management interviews, some of the things that some of the themes, and this is ongoing, that I found is that the business is built on relationships and communication, and that COVID-19 changed the way that emergency management officials operated tornado shelters. A common thread is that the emergency management officials discussed how they use the resources they have at their disposal to help their citizens. And so before I finish, I want to thank my advisor, Dr. Ash, and my entire thesis committee. I'd like to thank the SOARS program that I did a lot of this research during the summer last year. And I also like to thank NOAA for providing and sponsoring the survey data set. Thank you all.
Good. Very good, very good. Questions from our audience? I did have a question concerning the groupings real quick. Would you perhaps consider single-family dwellings are very different from even townhouses and condos, and putting those together, I'm not sure if they belong in the same. Did you maybe perhaps consider using 3 groups, splitting it up, townhouse, condos, and then single-family dwellings, and then your less sturdy group?
You know, that's a good suggestion, Dr. Fick. We started out doing this 2 groups, but I think there's no reason that we couldn't do 3 groups. And I appreciate you for providing that suggestion.
I'm just thinking, you know, about when I always see these tornadic damages and things that happen in these severe storms, many times apartment complexes get hit as well. And mobile homes are always the ones that seem to bear the brunt of the storms, but certainly apartment complexes as well. And it might be interesting. You get a different density level. So if you could break it down on density levels or something. Anyways, just a suggestion.
Thank you.
Any questions out there? Okay, thank you, Christopher. We're going to move on. Tierney, Szymanski, you're up. You're going to share your screen with us. Thank you so much. Looking good. Okay.
Okay. Hi, everyone. So my research is looking at the effects of governance and scale on community conservation in Southern Africa. Community-based natural resource management, or CBNRM, supports livelihoods and concerns governance management and the use of natural resources and wildlife. But despite the agreement on the importance of CBNRM, performance is often disappointing, and key issues emerge that are showing the lack of devolution within community governance. My study assesses the importance of Ostrom and Murphy's call for inclusive decision-making by all people impacted by the decisions through face-to-face participatory governance structures in small communities like villages. The differences between single villages, which are participatory governance, and multi-villages, which tend to be representational style governance, is illustrated below in the Child 2019 image in the context of CBNRM in Southern Africa. The image below shows the difference between representative or committee-based governance and participatory community-based governance. It also shows the issue that ecologies of scale and economies of scale, meaning larger environments are more functional than smaller ones, and that large areas earn more money, are better managed at large scales. In contrast, equitable benefit sharing and informed participation are better managed at small scales. To solve this issue, devolving the rights to the lowest levels and then delegating upwards when necessary is key. The data that I used for this study was collected between 2007 and 2009 from 17 different CBNRM communities by Drs. Child, Patricia Mupeta-Mwangwa, Shylock Mwangwa, and Roger Zubilo. I then was able to compile, clean, and analyze all of the surveys into one major set. The governance dashboard surveys implemented in these CBNRM communities are used to examine attitudes towards wildlife, governance, and the implementation of CBNRM practices. The main purpose of this study was to look at how satisfaction with community-based natural resource management is affected by the enabling environments such as country, different governance indicators, and the implementation of, and community size, which is also reflecting the type of governance. Key variables of interest were the difference between small single villages with participatory governance and larger multi-villages with representational forms of governance. I was able to utilize chi-squared and logistic regression models through our statistic to analyze these surveys. If we look at figure 1, it's a map of the study area of the villages with village scale. Our multi-villages are indicated in orange, with our single villages being indicated in blue. Botswana has 2 Botswana trusts that are multi-village. Both are comprised of 5 different villages and 3 individual single villages. Namibia has 5 Namibian conservancies that are larger multi-villages. Zimbabwe has 2 single villages, and Zambia has 4 multi-villages that are community-based organizations in the Lupande game management area and 1 single village. When doing the statistical analyses, I used all of the selected governance dashboard survey questions on the top right to run a model. And from there, I was able to dredge and run all possible model combinations to get the best fit model that's displayed in the bottom of the screen. Looking at this model, it has the significant codes designated in gray at the bottom. And you can see that certain things ended up being more statistically significant than others. 2 of the most notable were the right to make decisions on the use of conservancy money, and do you trust the conservancy leadership to manage and account for your finances? When looking at these different variables, you can also see that I ran an odds ratio. So survey participants that trusted the conservancy leadership to manage and account for their finances were 7.7 times more likely to overall rate the conservancy in a favorable manner. Looking at single versus multi-village, the survey participants who were in single villages were 1.69 times more likely to rate the overall performance of the conservancy in a favorable manner. One of the surprising results that I got from this study was that attending the last annual general meeting was not something that came out as statistically significant in the best fit model. But the findings support my hypothesis that variability and satisfaction is affected by country, different governance indicators, and scale of the village. This assessment of community member satisfaction with these CBNRM organizations suggests that governance and participatory practices must be considered in the design and implementation of CBNRM initiatives, and that small communities were providing statistically significant advantages in terms of financial transparency and trust, social capital formation, participation, and member satisfaction. I would also like to thank my advisor, Dr. Brian Child, as well as Leandra Merz for their assistance on this project.
Okay, thank you very much, Tierney. We'll open it up for questions.
I have one. Hi, Tierney.
Hey.
So your survey data is well over 10 years old now. Just wondering why you use that particular data.
So this data was used because it hasn't been analyzed before, as well as the impacts of COVID on being able to get in the field and collect more up-to-date data. I think that this data would be really good to look at again if we're able to get back in the field, go back to these communities and see how their attitudes have changed and things like that.
Yeah, thank you. Yeah, I kind of thought it was probably COVID related. But yeah, glad that there was a data set available.
Tim, I got a question. Are you hearing me?
Yeah, we hear you, Pete.
Yeah. Tierney, I was interested in the difference in the coefficients and the difference in the significance for the 3 different countries. Did I miss that? or we got? I mean, they've got. Why do you think they're different?
Yeah, so the countries came up as statistically significant, but in different ways. I think that this could be an indicator of perhaps trickle-down effects from governance in the more broad sense and how it affects the implementation and the structure of communities. I also think it could have something to do with perhaps the development of CBNRM practices in these different communities and how they evolved.
So do you think there's, I mean, does the negative coefficient for the really high negative coefficient for Botswana say to someone like me that they're doing a better job of communicating or a poorer job? I don't, you know, just, is there any sort of interpretation you can put on it like that?
I think for that, then, that Botswana would be one of the countries that overall were rating the Conservancy less favorably.
Zimbabwe really doesn't like it at all. Okay, that's, I mean, it's interesting because I know this is something that when we were messing around with various vegetation types and policies, you know, one of the key things was to see if the different countries stood out differently, if governance in each one of the countries had some impact. So it's cool to see it coming out there.
I have a comment, and I can turn it into a question. But for example, if I know the Conservancy chair and I'm in Botswana versus I know the Conservancy chair and I'm in Zambia versus I know the Conservancy chair if I'm in Zimbabwe, your model doesn't pick that up because there's no interaction effects between knowing the Conservancy chair and the location. Did you consider locational types of interaction effects where variables of this nature can enter into the model? Was that part of your, because you look for the best overall fit model in your search, did you have these type of interaction variables in that model before you?
So as far as interaction terms, I did not run any interaction terms for this model. That was going to be something that I was going to look at as well. But regarding this best fit model, there were no interaction terms that were run.
Okay, well, that's a suggestion. It's something to try. I mean, you did pretty well in terms of your pseudo R square. Usually if you get above 0.25, you're doing really well with these models. So it's actually a good sign. So I congratulate you on that. Okay. Anybody else? Questions? Anybody else? Okay, well, thank you, Tierney. I'd like to make a couple of statements here. There will be physical copies of these posters available for faculty to look at. Jane is going to, she already has them printed out. She's going to post them in the grad lab. If any faculty members or grad students or anybody wants to go look at those posters and perhaps contact our presenters and ask them further questions, they can do that at that time. I thank everybody. You guys did a great job. Thank you so much. Amazing Masters of Science students in geography we do have, and that's proof is in the pudding. Amazing research. So thank you. Continue on. We'll see you next week. Bob Walker's